In this tutorial, I'm going to go over a complete guide to Python user-defined functions, or how you can build functions yourself in Python. First of all, why would you want to do this? Well, if you're writing scripts of Python code that are 20, 30, 40, 50 lines long, there's likely not a requirement for reusability. However, when you get into Python code that's hundreds or thousands of lines long, you will get to the point where you want to package up certain elements following the DRY, the dry principle. Do not repeat yourself. You want to be able to work through your code in a logical manner, and segregating code that you may have to run over and over again will be very beneficial because it will allow you to debug more efficiently, and it will also simply save you repeating lines of code and making your actual file more efficient. It also makes sensible to chunk things up into more logical processes so that when you're going through or revising code, or someone else within your team is, there's a clear structure and you can state these functions at the start of your code and work through it. So that's a bit about why you may want to use Python functions. And they're very common and absolutely foundational, so really important to get your head around. However, in this first section, before I dive into a lot of real world examples, I'm going to go over the syntax. It's worth noting that in the next part, I will be covering a lot of real world examples to try and get you inspired, because often when you look at user defined functions, the examples aren't great. They're usually adding up a few numbers. So I want to take in examples like calculating weekly pay with overtime, temperature conversions, that will be more practical and hopefully get you inspired as to where you can implement Python user defined functions. So, this may look a bit intimidating. Truthfully, it's not. We have a few key elements that I'll go over. So, you may have seen this def keyword before, and essentially that's how you define a function within Python. Next up here, I'm simply naming my function. So I'm going to call this reusable block of code Celsius to Fahrenheit. I'm making the name as descriptive as possible because I'm just performing a temperature conversion. And here we have an argument that you may see shortened to arg or args. So this is just going to actually be the temperature that the user inputs down here when we call this function. Now, next up here, we have our block of code. Now, this is just essentially what you may just type out sort of freehand within a Python script if you only need to run it once. There's a very repeatable code or calculation to convert Celsius to Fahrenheit, and that's just to take the Celsius temperature, multiply it by 1.8, and add 32, and that will give us our Fahrenheit value. So what we're saying here in this block of code is to the Fahrenheit variable, very standard Python code, I just want you to take the Celsius temperature that the user has defined here when we call the function, multiply it by 1.8, we specify it within parentheses to run this first, and then we add the value of 32 to that result, and we return Fahrenheit. We're not putting a print statement within a function because it's not the best way to do things. What we want to do here is just say, right, these two lines that are indented, it's the code to be run. Once you've done this, use the return to exit out. And this isn't going to do anything until we call it. So we use the print statement to print out the value of that conversion, which is based on the value of 22 Celsius, and we need to call it. Now, it's helpful to think of this function as just being defined at the start and storing the code. It's not actually doing anything. We can print lots of lines of code after this, and as long as we didn't call this function, nothing pertaining to this function here will display. It's only when we actually call it here with Celsius to Fahrenheit and specify an argument that this will run. So that's important to note. So to go back over the key functionality again, in this top line, we're defining our function. We need to have that keyword def or else we can't do it. We're specifying a name, so I've just called it Celsius to Fahrenheit, and an argument, which is going to be the value that the user inputs. We need a colon, part of the syntax, to then indent the next lines. Now, these are nothing more than code that you may use just freehand within a Python script. It's just our calculation assigned to a variable, and we're just saying once that's established, just return that value. Nothing else happens. And then we call it because we want to print the values out to the terminal. And we're saying to print the Celsius to Fahrenheit function, And our argument, the temperature that we want to convert in Celsius, is 22 degrees. So hopefully that's helped you understand the syntax more. I think functions can often look a lot more intimidating, especially when they incorporate things like data type conversions, conditional logic like if, elif, else statements, but I'm going to go over a number of these things and gradually increase the knowledge. So that should cement. So in this next section, we'll actually look at some examples and hopefully that founds a really more exciting part of this tutorial. So now we can actually look at some real examples based on real world situations to get you thinking the right way to potentially segment, tidy up your code, and really adopt functions in the best way possible. So I'm using a notebook. You'd ideally be using an IDE most likely, VS Code, PyCharm, something similar, Atom. And the reason I'm using this is just to segregate out each of our different examples purely for demonstration. So the first example that we have is just a simple function that we've built ourselves, a user-defined function, and we're just specifying one parameter with that return statement. So again, we've defined our function as Celsius to Fahrenheit. We've got the argument temp for temperature, the Celsius temperature, and within this block, what we're actually doing, what our code is actually made to do, is we're just assigning to the Fahrenheit variable the Celsius temperature multiplied by 1.8, of course, within parentheses to execute it first. We add the value 32 and we return that variable, the value of it. And then we go ahead and print the result of calling that function, Celsius to Fahrenheit, just the function name, and adding in the argument, so the Celsius value in temperature. And of course, we get the value 71.6, which is the output of that Celsius to Fahrenheit conversion. Now, in a script that's short, we could just run this once, but if we had a lot of different values needing to be calculated at different points, it's very helpful just to have this function defined at the start of our code, and we can go ahead throughout and run it. So that's a simple example, just with one single argument. But what happens if we go on and we specify more than one argument or parameter? So here we have multiple parameters. Now, it works just in exactly the same way. We define our function, which is just called price with tax, but maybe we want to specify a different tax rate or the user has to input a different tax rate depending where we are. So instead of inputting one argument, we just simply input two arguments separated by a comma. That's price and tax rate. We have our colon, and then we will automatically get an indented line for that actual function block. And then again, we just need to specify what we want to do. So we're going to want to return the price that we specify, so user input, so it could be a price of an object, a good, a service, whatever that may be. And again, in parenthesis, so what we actually want to do, let's say if it was a tax rate of 20%, we just want to multiply the value by 1.2. However, we can't hard code it in because the user needs to specify the tax rate. So what we actually do is we can just multiply that by the value 1 plus the tax rate. So that was 1 and the tax rate is 0.2, 0.2. That would mean all we're actually doing in this function body is returning the price multiplied by 1.2. So again, there's no real difference here with multiple parameters. We just have to specify it within the argument section here, and we just have to call two values for those arguments. So again, we're saying we want to print the output of this code block, the function, and that's price with tax. So we are specifying a price of 14.99, and the second argument is the tax rate, and of course that will be multiplied. So we're essentially doing 14.99 multiplied by 1.2 because we don't just want to isolate what the tax rate is. We want to add that on to our whole value to get whole price with tax. So when we run that, we get the value, it's fine, to 3 decimal points, a float value, which is 17.988 or 17.99 if we were to go and refactor and adjust that to 2 decimal places. So multiple parameters doesn't behave much differently. But while we were on that subject, I wanted to go over a slightly more complex example to show you how we can really start to make functions work for us and make them more fruitful. And a fruitful function is something that actually will return a value. So that's actually a bit of technical jargon there as well. So in this example, the third example here, we have a function that we've defined and called calculate gross pay. Again, we have two arguments, hours worked and hourly rate. Now, this is a bit more complex because the logic behind this is if the hours worked are less than or equal to 40, that's just a standard full-time week. So we can just calculate the gross pay as the hours worked multiplied by the hourly rate. However, what we need to do here is actually within our function, instead of writing lots of different if and else statements, this is where functions are good to avoid that repeatability, we can have an else statement that calculates the overtime rate as well in one shot. So we can say if the overtime hours, essentially, because it's the opposite of less than or equal to 40 within our else statement, are greater than 40, what we can do is we can take our overtime hours and set that equal to the amount of hours worked minus 40, because we don't want to pay overtime on any values that are over 40 hours for the week. And then we can calculate the gross pay again as equal to 40 multiplied by the hourly rate, and then we want our overtime hours to be the hourly rate times 1.5, which is time and a half, essentially. You get a bonus, an extra bonus there because you're working over your weekly hours. And then you just want to add that all together and return gross pay. So what we're doing here, the multiple parameters behaves exactly the same when we call it, but we can actually introduce conditional logic if and else statements. We could have a third condition that's an elif if we like, and then we just call it in exactly the same way. We calculate the gross pay and we've specified the value for 30 hours worked, so we won't need to go into this else condition, and we've got 25 as hourly rate. So all we're actually doing here in this body is saying, okay, the hours worked are less than 40, fine, we'll evaluate this first condition, which is gross pay, which is hours worked 30 multiplied by the hourly rate 25, and it says that's evaluated to true. I can ignore this else portion. I'll go straight to my return. Okay, I can come out of my function. I'm not doing anything with that yet, but now it's been called, I can. So I'll apply those values into the arguments, and what I'm left with is a value of 750. So it's a really nice way to look at a bit more of a real world example and how you can go ahead and start to power up the work you're doing with functions. Now, what's interesting is that we also can specify default parameter values. So if we call the function without an argument, ordinarily, or too many arguments, that's actually going to result in an error. And we don't want that to happen. We don't want people to have zero values or errors. So we can go ahead and actually specify a default value. So in this function, all I'm doing here to illustrate is I'm just naming a function, data type, and defining it. But I'm saying here that I just want to return the type. Now, I can specify the type as a standard argument, so here int, and that would just print integer. But you'll see here within the argument, I've got type is equal to string, which is something we've not seen before. So what this is saying is if the function in this first example, it would just evaluate to int because we've specified our type argument. However, um, in the second option, second print statement, we haven't specified a value, and we don't want that to error out. So we're saying, well, we don't want our whole Python code to fail if someone forgets to input a value. So we'll just give that the default value of a string data type instead of an integer, because integer was specified before. So now if we run this code, we get int for integer as the first type, because in our print statement we've said that. That qualifies as a type, so that's fine. Now in the second example, instead of being blank and equating to an error, we actually get that default value of string. So they're really helpful to avoid errors. You can wrap things in try except blocks and specify default values as well. That way, things for value errors or value exceptions. But this is a really nice way to do it, and it's important to note. Now, the two last things I want to look at are quite similar, but they're args and kwargs. You might see them shortened as. And what that is arguments, which is a non-keyword argument, or a keyword argument as KWARGS, Kwargs. So we have here in this example is the running total, but you'll see here we have an asterisk in front of our usual parameter. Now what this is saying is we don't know how many arguments potentially are going to be specified. Now, the issue with that is if we just specified, two different arguments in the setup here when we define the function, someone may want to add 3, 4, 5, 6, 7, or one argument maybe. And all those different options would actually throw an error. So if we don't know how many arguments someone's going to supply, we can just use an asterisk to denote that it's going to be a keyword argument, a non-keyword argument, one asterisk, and then we just have to name our argument again. So here and here we're saying within our function code block, we'll start a counter with total, the variable equal to 0, and we'll run a for loop, and all this is going to do is essentially run a cumulative score. But it means that we can specify we're not limited to defining the amount of arguments. You'll see here, all of these are going to run, but we have 2 arguments here, 4 arguments, then 1. And we're not going to get any errors because we've specified a non-keyword argument, or args, that you may see it shortened as. So we just run a loop, and we take standard for loop syntax. So for the score within the scores argument here, we're just going to use the plus and equals operators to simply add that on to the value that came before, and we will return a cumulative total. So when we run this here, we will see that the first line is 3, the second line equates to 2 plus 6, which is 8, plus 7, which is 15, plus 9, which is 24, and the third line 10. But because we didn't know how many arguments were going to be supplied, we're successfully able to specify an asterisk before the name of our argument for a non-keyword argument, and people can go ahead and specify as many values as they like. Now, similarly, we have Kwargs. So these are just keyword arguments. And this is just similar to what you would see with a dictionary, where we need to specify 2 asterisks to denote that it's a keyword argument. And then what we can do is actually specify a value. So almost like a dictionary, specify a value to an actual keyword. So in this example, we're looking at total marks. Again, we're adding up values, cumulative values for each line here within the print statements. But again, we don't know how many arguments will be supplied. In the first, we have 3. In the second, we have 2. But this enables us to actually specify it as a dictionary, essentially, where we're assigning a value to a specific keyword. So what we can do here, we need to remember that essentially we're just giving an argument with 2 asterisks to denote that it's a keyword argument rather than a standard argument. And we're doing the same thing again within the body of our function. We're starting at 0 with the total. However, we need to use the dot values function to actually access the value within our keyword argument. And then again, we just sum the values and return them. So when we run this code, we get 200 for the first line because we're just taking the values from each keyword argument. So that's 50, 120, 200 when we sum the 3 keyword test scores, and chemistry and art equates to 140. So that's really valuable if you want to work with data types like dictionaries. Now that's a pretty comprehensive tour of functions, but I hope not only it's cemented some of the knowledge, you're starting to think about where you can use this, but it's also giving you some real world examples to foster some creativity and realize where you may be able to use this. If you go into professional projects or you look at code potentially in GitHub, you will see at the start of code scripts or code files, there are regularly functions defined there. So hopefully this gives you an idea about the reusability and the huge array of benefits that Python functions or user-defined functions can provide for you. As usual, if you like the content, please feel free to like, comment, subscribe, and share. Thank you.